Good morning. I can draw conclusions without any givens using vertical angles when lines intersect and reflexive property when a side/angle is in both triangles. So we talked about doing mini proofs. Now we're going to talk about the two conclusions, the only two things that you can do without givens. The first one is going to be vertical angles, which we've talked about already this year, just not in the proof setting. And then we're going to talk about what reflexive property is. So we're going to start with reflexive property. Reflexive property is when we have a side or an angle that's in both triangles. So I'm going to write my statements, reasons. Everything on this assignment is going to be one statement, one reason. There's no givens. Now what I'm doing is I'm asking you to prove these triangles. All I'm basically saying is to look at these triangles. This is just one step within a bigger step. We're not actually proving the triangles are congruent, but we need to know which triangles to look at. Basically, I'm saying if I were to prove these triangles are congruent, I want to see the conclusion I can draw without any givens. So we're looking for a side or an angle that's in both the blue triangle and the green triangle. Now, a lot of students say, well, what about angle L? No. Angle L, there's two angle L's. There's MLN and there's KLN. Even though they both have a vertex at L, they're not the exact same angle with the exact same letters. So no, that would not be an example of reflexive property. The side or angle that's in both the blue and the green triangle is LN. And I mark when I have a side with reflexive, I generally mark it with an X. So basically I'm saying, well, LN from the blue triangle is congruent to LN from the green triangle. It's a side of the blue triangle, it's a side of the green triangle. So here's how I would put that into the proof. LN is the side that's in both. So I would say that LN is congruent to LN, and the reason would be reflexive property. So if there's no given, but there's a side or an angle that's in both triangles, I state the side or angle that's in both triangles is congruent to itself. Reason, reflexive property. Number 2 is very similar. It wants me to prove triangle DBA is congruent to triangle DBC. So I'm looking for a side or an angle that's in both of these triangles. So I want you to take a few seconds and I want you to try and find the side or angle that's in both triangles. DB is in both triangles. So my statement is DB is congruent to DB, and my reason is reflexive property. We're looking for a side or angle that's in both triangles. Once we find it, I state that that side or angle is congruent to itself. Reason is reflexive property. Let's skip ahead to number 4. Now, we're not going to be doing similar triangles yet. That's what the symbol is similar. But all I'm really concerned about is finding the reflexive piece. So I've got BDE, that's the black one. I've got BAC, that's the blue one. I'm looking for a side or an angle that's in both triangles. I see it. A side or angle that's in both the blue triangle and the black triangle. Angle B is in both triangles. Angle B is an angle of the blue triangle. Angle B is an angle of the black triangle. So I state angle DBE is congruent to angle DBE, and the reason is reflexive property. So the first couple of examples we did are examples that deal with sides, but reflexive property can also happen with angles. In fact, I'd say in the regions it probably happens more so with angles than it does with sides. Let's take a look at this next one. ABC. Let's go purple. And ADE will go blue. I'm looking for a side or an angle that's in both triangles. So take a look if you haven't already. And my side or angle that's in both triangles is angle A. Angle A is in the purple triangle, angle A is in the blue triangle. So I'm going to say that angle EAD is congruent to angle EAD, and my reason is reflexive property. So that's basically it for reflexive property. There's a bunch more practice examples that you can try on your own, but you're looking for a side or an angle that's in both triangles. Once you find it, you state that it's congruent to itself, and the reason is reflexive property. So, number 9. It wants me to prove SAE, RAB. Is there reflexive property? Is there a side or an angle that's in both triangles? No. There's really no overlap to them. There's a point that's touching, but a point is not a side or an angle, so there is no reflexive property. So the other thing to look for is vertical angles. We learned about vertical angles earlier this year, and vertical angles are formed when we have an X, when we have intersecting lines. Yep, I see vertical angles right there. So here's what we do. We name them. Angle SAE is congruent to angle RAB. And the reason is, and you're seeing this for the first time, vertical angles are congruent. So there are two things that we can conclude without givens. There's reflexive property and there's vertical angles. When we see an X, when we see intersecting lines, vertical angles are formed. Once we identify them, name them, and the reason for vertical angles is going to always be vertical angles are congruent. You need to write are congruent. I've had 2 students who got a 64 in the regions because they didn't get a point when they just said vertical angles. If they would have just wrote vertical angles are congruent, they would have gotten a 65 in the regions, they would have passed. So it's that, it's that important that we're writing things properly. Number 10, it wants me to prove that TAE is congruent to CAH. There's no givens, so I look for vertical angles or the reflexive property. Do I see vertical angles? Do I see intersecting lines? Do I see an X? Yes. So I name them. Angle TAE is congruent to angle CAH. And the reason whenever I have vertical angles are congruent. I want you to try number 11 on your own right now. I'll just start by highlighting the triangles that we're looking at, although they are pretty obvious here. SBA, EBR. I want you to try this one on your own. So I'm going to give you about 30 seconds right now to try this one on your own. Okay, there's no reflexive property. There's nothing that's in both. There's no overlap. I do see vertical angles. So my statement, angle SBA, is congruent to angle EBR. And the reason whenever I see vertical angles are congruent. So your classwork/homework is to finish this assignment, although I'm pretty sure I'm giving you a second assignment today as well. But you need this piece in order to do what we're going to be doing in a couple of days. So again, I can draw conclusions without any givens. There's only two things you can do without givens, and that's what we just learned about: vertical angles and the reflexive property. Vertical angles when you have an X, reflexive property when you have a shared side or angle. Have a good day.